Hello everyone, I'm Weiping from Colorado School of Math. The topic I'm going to bring you is quality control in crowdsourcing based on fine-grained behavioral features. My co-authors are Zhiju, Monchu, Chen, and Chuan. Crowdsourcing is popular for large-scale data collection and labeling nowadays. Job requesters break a large task into many smaller subtasks, and each subtask consists of one or more units as shown in this figure. So take the textual emotion recognition as an example. The requester would like to collect emotion annotations for a set of dialogues. In this case, each dialogue is a subtask, and each dialogue may consist of multiple utterances, and therefore each utterance is a unit. Therefore, the annotations collected from workers could be divided into different levels of granularity: the unit level, the subtask level, and the task level. In our paper, we defined unit level as fine-grained level, the subtask and task levels as coarse-grained level. Why crowdsourcing platforms are widely used nowadays, quality control has become more critical and challenging. One popular approach for quality control is the gold standard, which compares a worker's submissions against a set of labeled high-quality data. Another approach is to introduce redundancies, so which assigns the same subtask to a number of workers and then infer the consensus label by using aggregation methods. Recently, another popular approach is behavior analysis approach, which estimates data quality by analyzing worker behavior, such as the mouse clicks and key presses. Compared to the gold standard and the redundancy analysis approaches, this approach can help reduce cost and be feasible for scaling up. However, there are some limitations for existing behavior analysis approaches. So first, existing approaches primarily leverage coarse-grained behavioral features and did not further explore quality control at the fine-grained level. This can lead to the inclusion of low-quality data, exclusion of high-quality data, and all manipulations by malicious workers because they ignored workers' time-varying behaviors among annotation units in the same subtask. Take the textual emotion recognition as an example. This, as shown in this figure, workers may carefully perform the first half utterance in this dialogue, but become sloppy and try to complete the rest utterance quickly. Therefore, we can get the high quality for the first half utterance, may get the low quality for the rest. Coarse-grained behavior features cannot provide the details for each utterance and therefore ignore the varying quality within this dialogue. Besides, existing studies did not consider the subtask consisting of varying number of units or behavior analysis for subjective tasks. The goal of our research study is to investigate feasibilities and benefits of using fine-grained behavioral features for quality control in crowdsourcing. In this paper, we design and implement a framework named Fine-Grained Behavior-Based Quality Control, FBQC framework. So as shown in this slide, we extract workers' fine-grained behavior features and provide 3 quality control mechanisms. Specifically, there are 3 components in our framework. The first component is fine-grained behavior monitoring. So the data collection occurs on a worker's web browser. We insert a JavaScript code to the task web page to monitor workers' activities and log their interactions with the task, such as the mouse movements. The second component is a is the feature extractions at multiple granularities. We consider both the behavioral features and the task attributes at different granularities. So in our paper, we conducted two tasks, the image task and the test task. So for the image task, the workers are presented with an image and they are asked to draw bounding balls to locate all people in the image. Each bounding ball corresponds to a unit, and each image corresponds to a subtask. For the test task, workers are asked to annotate emotions for each utterance in a dialogue. So each utterance corresponds to a unit. So in the image task, the unit behavior features are workers' interactions when creating a bounding balls. For example, the time they used to draw a bounding balls for the woman in this figure. However, the subtask behavior feature, which have been widely used in existing study, are the total behavioral information, such as the total time the worker used in this image. Similarly, for the test task, the unit behavioral features are specific to each utterance, while the subtask behavior features are for the whole dialogue. So with features extracted at different granularities, the third component, multi-weight quality control, provides three mechanisms to help requesters or crowdsourcing platforms control data quality at different levels. For objective tasks that have ground truths, such as the visual object detection, we provide quality prediction. In this case, we train supervised models based on extracted features to predict data quality. For subjective tasks that do not have ground truths, and we consider the suspicious behavior detection, so in which we define a set of rules to identify suspicious behaviors. For unsupervised worker categorization, we consider unsupervised clustering algorithm to group workers. To evaluate the effectiveness of three quality control mechanisms in our framework, we conducted the image task and test task on Appen. Because the image task is objective task, we consider the quality prediction for quality control. Our experimental result shows that it's feasible to predict qualities at the unit level, and incorporating fine-grained behavioral features help improve accuracy of quality prediction in the subtask and task level. For the second quality control mechanism, suspicious behavior detection, we evaluated it on the test task, which is a subjective task. We achieved 90% accuracy at the unit level, which validates the effectiveness of our proposed approach. For the worker categorization, we conducted analysis on both image and test image. Our experimental results shows that using unit behavior features benefits worker categorization. All evaluations on all three mechanisms demonstrate the feasibility and benefits of using fine-grained behavior features for quality control in crowdsourcing. So our framework is highly deployable by either a job requester or a crowdsourcing platform, and can be implemented in different types of crowdsourcing tasks, such as the ones shown in this table. We can extract the corresponding fine-grained behavior features and the coarse-grained behavior feature. For conclusion, we explore the feasibilities and benefits of using fine-grained behavior feature for quality controls at fine-grained levels and also at higher level. We designed and implemented the FBQC framework. We conducted two real-world crowdsourcing experiments and demonstrated using fine-grained behavior feature are feasible and beneficial in all three quality control mechanisms. Our work provides clues and implications for helping job requester or crowdsourcing platform to further achieve better quality control. That's all my presentation. Thank you.